who's still trickling in. The door is open. Today, I'm going to be talking about making you a better speaker with Spring AI. A recent study from MIT has shown that if you include the word AI into the title of your presentation, the participation rate goes up by nearly 1,000%. So thank you, AI, for bringing people today. And thank you all, of course, for coming. Since AI may have clickbaited you into this talk, let me introduce myself. My name is Sergey Kryvets, and I'm a software engineer lead at First United Bank. However, today we're not going to be talking about financial services. Today we're going to be talking about something that is personal to me. A quick disclaimer, I have not been paid, bribed, offered, or free coffee to promote anything. Everything that you're going to be hearing about today is fueled by my own curiosity and a bit too much caffeine. With that, I would like to share a quick story. A story that inspired me to make this talk. A few years ago, at one of my former jobs in 2018, I had to present to an audience of about 50 people. Even though I was a key person on the project and knew the material inside and out, as soon as I started working on the podium, I felt so much stress. And when I came on the podium, I was so paralyzed by fear that I can not basically say anything. It was a total disaster. My face was looking like this. This when I realized I need to improve my public speaking skills. So I signed up for the course, and after a few years, I was even able to participate in a local area contest where I won first and second place. And I know by experience that public speaking is not a talent that you're born with. It's a skill that is acquired through practice. That's why today we're going to build an application that will help us all to do exactly that, to become a better public speaker. But as with any application, we need to define first a set of requirements. And in our case, the requirements are what makes a great speaker? And that would be my question to all of you. What do you think are the qualities that make an outstanding speaker outstanding? I need 4 items. Knowledge on the subject.
Connecting with the audience.
Connecting with the audience. Piqued audience interest. Confidence. Perfect. I'm sure if you think about for longer, you can come up with 1,000 more things, and you'll be right. Because there is not a single skill that makes a great speaker. It's a combination of high-level, macro, micro, and nano skills. Since it will be too many to go through in one talk, I picked 4, which are clarity, credibility, confidence, and conciseness. There is one problem. There is one thing that can absolutely destroy all those skills. Can you guess what this is? Maybe. I'm going to say the same sentence twice, and we'll see if you can hear the difference. Here's go the first one. A few of the most important traits of any software developer are problem solving, curiosity, and humility. An ability to admit that we don't know everything. Here goes the second one. A few of the most important traits of any software developer are problem solving, curiosity, and humility. You know, the ability to admit that we don't know everything. What was the difference? Filler words. Bingo. But the filler words are only part of the problem. Many speakers, including myself, don't even realize that we use the filler words. In my second presentation after that failure, I didn't stumble, and I thought I did great, only after to hear the recording and realized that every 3 seconds I did and It was very hard to listen. That's why today we're going to build this, a speech coach application that is going to translate our speech. It is going to, all that using AI, is going to highlight all the filler words. It is also going to provide a crutch word count, how many of each crutch word was used, and a fluency score, a measurement how fluently someone speaks. It starts at 100 if no filler words were used and goes down as more filler words were used. A little bit about tech stack. I'm going to use React on the front end and Spring Boot on the back end. Since this talk about Spring, I already have front end part ready, and we're going to build and live, and what's more in the way to say it, wipe code our Spring backend from scratch. Since it's going to take me some time to initialize the Spring backend, I'm going to go ahead and navigate to best place on the internet to initialize Spring, which is spring.io. We would need a few dependencies. I'm going to do web. I'm going to do, let's do DevTools. Of course, because it's AI, I'm going to do OpenAI. And I'm going to use Lombok. I know Lombok is controversial, but Danny only gave me 25 minutes. If you don't want to see me using Lombok, talk to Danny. I'm going to blame him. I'm going to hit generate and open in my IDE. While this is loading, I'm going to talk for front end for about 1 minute. Even though they seem like quite a few things going on, in the reality, the front end is really dumb. It only does 3 things. 1, it does record the audio. 2nd, it sends the audio stream to a backend. And then the 3rd part, it maps the response from the backend to the UI. So there is not really too many things going on. All the processing is done on the backend. Hopefully, if I open my IDE, we can see that application is already finished loading. And I'm going to navigate to the main class. I'm using Java 25, and with Java 25, we even need to use less keywords to define a public static void main method. Public is no longer needed. But we're building a web application, and as with many web application, we'll have a controller. Oops, I'm going to remove all those imports. Our controller is going to have transcribe endpoint, which is going to accept an audio stream in the form of byte array, and it will produce an app response. What is the app response? App response is the response model that has text from our audio. It has a list of crutch words, frequency, how often each filler word was used. Crutch word ordinal is the one paste index position of the actual crutch word that was used in a sentence. Because if I say things like, I like the cake, like is not the crutch word here, and as we talked about, the fluency score. Now, to make sure that our application works end-to-end, I'm going to return hard-coded response. I'm also going to log the request that comes into play here. Perfect. If I'm going to start this application and switch to UI, if I hit record and immediately stop it, even though we did send the data, it came back as a hard-coded data, but we proved that our flow works end-to-end, which is pretty cool. Now let's do the real stuff. We're going to inject and use AI. And for that, first thing we're going to do is we're going to transcribe our speech. And what's the better way to do this as to build something called transcriber service. This service, I think I made a typo. Let me fix that. Perfect. Now, since this is ready, this service is going to have one method, which is called transcribe. It's not going to accept the byte array, but rather resource from Spring resource, which we'll see why in a second. Now, we will use audio model from OpenAI, and Spring provides very convenient class, which is cryptically called OpenAI Audio Transcription Model. Very hard to guess. And this class is very easy to use. The only thing we have to do is to call method on it and pass the resource. At the end, we're going to get transcription. Oops, hold on. Which we will return in this method. The only reason I don't return it right away is because I want to log it. Thank you. Perfect. Now, the last thing that I have to do is to go back to my controller and wire up this service. Perfect. Now I have to pass. Okay, here's a trick. We accept audio stream, but we need to pass a string resource. And when we work with audio files in transcription, OpenAI actually deals with files. Files has file names, but audio stream don't have file names. That's why I will create an abstraction or wrapper, byte resource array. Hold on. A little bit the other way around. Hold on. Let me delete this. What was that? App resource byte array? App byte array resource. Hold on. Not this one. Perfect. Now, perfect. That works. I did hardcode the file name as the audio stream webpm, but it can be anything. Doesn't really matter. Now, yeah, if I'll go back and now wrap my audio stream, thank you, Copilot, I'm going to pass the resource and get the transcription back. I'm doing so many typos. Now I'll replace the hard-coded app response with our transcription, which is a text. If I restart the backend, and now I need to come up with some creative sentence. Yesterday, I came to my boss and told that I shipped my code to production and everything was on fire. Okay, perfect. We got back the transcription. However, it did cut all the filler words. And if you think about it, that makes sense because you don't want to see crutch or filler words in your meeting summaries or YouTube captions. And this is what models do. They bias towards removing all the scratch words. But in our case, it really defeats the purpose of our application, and we need to bias the model to not skip them and actually include. That's why we need to pass something called options. There are a few configuration options that I'm passing right here. One of them is the verbose JSON format. This format provides, instructs the model to provide more data with the response. It will include the metadata about the transcription, it will include timestamp, and also it has a higher chance of including the actual crutch words. This response format only works with the Whisper model, that's why I'm including it here. And we also send in the prompt alongside it to further bias the model to include the filler words. It basically tells the model that you should expect to see those words, they call like seed words, and not leave them out. Now I'm going to say the same thing one more time. Hold on, I did not wire this up. I need to create audio transcription prompt, pass the resource and options. Now I'm going to create the prompt and change it to accept prompt right here. Now we're not going to get back a string, but rather metadata and the real transcription, and I'm going to log both, but I'm only going to return the actual transcription, the actual text that we get from the audio. If I'm going to restart that part, I'm going to say it again. Yesterday, I came to my boss and told that my code broke production. Oh, wait a second. Perfect. Boom. Now it works. Very, very cool. We see arms that I made in here. But the problem, those arms are not highlighted, and we still have, and the reason is because the analysis data is hard-coded. We still have this right-hand side, the analysis, being not real-time, right? So what we have to do is what we'll do right now is we're going to take the transcription and we're going to pass to AI again, and this time we're going to use something called chat model. And what the best way to do this other than implementing something called analysis service. This service will have, thank you, Copilot, analyze method. What we're going to do now, in order to talk to a chat model and let it analyze our speech, I'm going to wire Spring-provided interface, which is called chat client, which is very easy to use as well. Now, the chat client is not wired up by default, so I have to use the builder to build it and instantiate the bean in this way. Now, we see that my ID is no longer yelling at me. I'm going to start making a call to chat, OpenAI chat client API. So the way to do this is to use prompt, then user, which is a user prompt, and in our case it's a transcription. I'm going to do call, which actually performs a real API call, and the content, which returns a string. Now, if I'm going to turn a response, we're going to get a string back. The question is, how do we get this really nicely formatted output that we want, which contains the list of crutch words and everything else? Now, for that, we need to define a model, which I'm going to call AI analysis response. This model has everything that we saw in the previous model, minus the transcription, because the transcription is something that we already did in the other service. Now, the question is, how do I make this analyze service to return our response model? And the nice thing is, Spring has a very nice trick under its sleeves, where if we use entity, it can map string, not the string, but the response from the AI to the actual entity. And now entity has this model. I'm going to log it and return it. Perfect. The last piece that I have to do is to wire this up into my controller, pass analysis, and replace all this hard-coded data with the actual response from the AI. I think we have everything in place. Let me restart. And we'll go back, and I need to say another sentence. My code always works if you never actually run it. We'll see. Perfect. Whew, interesting. Now, we got the filler words back, but we got the analysis coming back as empty. And it's very similar to what we did in the last, with the transcription service. We missed one of the important things here. The piece that we missed is the instruction for AI how to operate on this transcription, because what we give to AI in the transcription and then the response output, it has no idea what to do with this transcription, has no context, which why we're going to provide something called a system prompt. A system prompt is the rules of the game for AI. It's going to instruct AI how to behave, how to analyze this text. What I'm telling it is that your strict text analyzer that finds crutch words in a provided transcript and returns a JSON object conforming to this schema. It's something that Danny was talking about, the guardrails and the instruction for AI. It's a very long prompt, but it also has examples what to do in this scenario. The last part that I have to do is to go back to my analysis service and pass the system prompt, which is very conveniently done via system method. That's it. If I refresh this and I'll start and we'll test it again, hopefully, it worked this time. My code actually always works if you never actually run it. Wait a second. That worked. I have total of 5 crutch words, and I said 3 times, and I said actually 2 times, because actually is actually the filler word that I need to actually use less myself. With that, we built a demo application where we learned about how to use OpenAI transcription model and other chat client with a Spring. The thing that we didn't do is we didn't spin up a new microservice in Python just to do the AI logic. If you're learning Spring Boot or learning Java, or your enterprise that uses Spring or Java, you don't have to create a new microservice at Spring, because Spring has a lot of things and integration with existing AI. It has integration with more than 15 models, including OpenAI, Anthropic, Gemini from Google, and many, many more. It has the tools to create MCPs, to consume MCPs, RAG, and all the good stuff that you hear in today's Lent. On the non-technical side, we learned that filler words are the speech killer. So the next time you're presenting, trying to use them less, because the absence of words is not the absence of communication. Thank you. Oh, sure. You can find all the slides, code examples, which are both React and Git and Spring Boot, using this link. I put them down. You can also find me on YouTube and on X, all these social platforms. And if you want to send me a message, I will more than welcome to respond to any of your questions. So thank you for coming, and I will. So what do we have on time? Okay. If you have any questions, I will be in the hallway. We can chat. I will be happy to have a conversation about AI. Thank you.